Hey VC students, welcome to the second part of the factorization crash course, and in this second part we'll be going through cubics. So if you haven't watched the first part on how to factorize quadratics, I'll leave a pop-up or link below so that you can find it and watch that first. And then now we're going to move on to factorizing cubics. So when you are faced with cubic, or it doesn't have to be cubic, it can be other polynomial functions as well. So it can be quartic, can be to the degree power 5, 6, 7, blah blah blah. But in methods and spec, you generally just get up until cubics most of the time. So again, I will list this in order of speed and efficiency. The ones that you should consider first when you are factorizing cubic is the sum, and excuse my handwriting, that is terrible, the sum or difference of cubics. Okay, so that is the first thing you should be thinking of. And then the second technique that you should follow if the first one doesn't work is grouping. Okay, so grouping is the second technique you should follow. And then the third technique, if all of them doesn't work, then you need to go through long division. And I'm sure everyone loves long division. You need to make sure you know all three different techniques for factorizing cubic expressions. Alrighty, so on to the first technique, which is the sum difference of cubics. This is essentially just applying a formula. The cubic formula that you have is a cubed minus x cubed minus a cubed, and then you have x cubed plus a cubed. So essentially what the formula is if you have this formula or this expression, then you can write it as x minus a multiplied by x squared plus ax plus a squared. And then if you have x cubed plus a cubed, then you get x plus a multiplied by x squared minus ax plus a square. And you can't factorize it anymore because essentially this quadratic equation over here, you can't factorize anymore. It's not in that format, our good old format, x squared plus 2ax plus a square. It doesn't have that too, so then you can't factorize it any further. Okay, and at the same time, any of these two techniques that we just learned in the previous video wouldn't work on this format either. So that's the first one, factorizing cubic using sum and difference of cubics. And then the second one you need to learn is grouping. So an example of this, and the best way to show is, I'll give you guys an example. X cubed plus x squared plus x plus 1. Right, so first of all, we try to use our first technique. It unfortunately is not in this format of x cubed minus or plus a number cubed. So we go to the second technique, grouping. So with grouping, essentially it's a bit of playing around with the numbers and the coefficients a bit. Can I group any of these terms together so I can factorize it? So essentially what you're looking at is try to group things together. So x cubed, x squared, can I factorize that? Well, you can potentially take out the square. So if I take out x squared, then you're left with x plus 1, right? And then on this the third and fourth term, you can actually write it as x plus 1 in a bracket. It's just a different way of writing this, but essentially ending up with the same expression. Now this is the reason why it's called grouping, and it's because you can now group the x plus 1s together, right? So in this case, because the x plus 1 and x plus 1 are the same, you can group them together, and then what you have left is, then if I take out x plus 1 from the first term, so consider this as two terms. So you've got one term, the first term, and you've got the second term. Now I take out x plus 1 of the first and second term. What am I left with on each of them? So in this case, the first term I'm left with an x squared, and then on the last term, well, essentially I'm just left with 1, right? Because I've taken out everything. So that means I'm just left with 1. And there we go, guys. That's how you then factorize this. Now we've got a linear factor and we've got a quadratic factor. The quadratic factor, unfortunately, you can't do much. You can't do anything else. So then that's our simplest form. So this is grouping. So essentially, guys, with grouping, you try to factorize some numbers first and see if you can get like terms. And then with those like terms, you group them and then you can factorize it further. Okay. So unfortunately, technique A and B doesn't always work. It requires a very specific type of expression. So for A, you need the cube and the cube, and then for the B, it just really depends on if you can form any groups. And then of course our favorite is long division. So if all else fails, guys, and you can't do any of the first two techniques, you go to long division, which is slightly longer than the other two, but it solves pretty much most, if not all, cubic factorization problems. So with long division, it is split off into three steps essentially. First step is what we call the factor theorem. So with factor theorem, essentially what you try to do is you try to look at your cubic expression, and we'll go through an example. This is probably the best way of doing it. And the example we're going to go with is 2x cubed plus 3x squared minus 11x minus 6. And factor theorem essentially just says, look at your last term and see if you can find factors of that last term, and when you sub that number or that factor in, can you get a 0? Okay, so what are we looking at? We're looking at number 6. What are the factors of 6? Well, you can get 1, you can get -1, you can get 2, you can get -2, you can get 3, and you can get -3, right? And then obviously as well, I'm sorry, I forgot, 6 and -6. So you need to just look at all these factors and just think, okay, if I sub a number in here, any of these numbers, which one would give me 0 as a result, right? So just to save some time, guys, I've done this before. If you sub in the number 2, then you would actually get a 0. So what I mean by that is if I take this factor, number 2, and I just sub into the x values, then we arrive at 0. So 2 times by 2 cubed plus 3 times by 2 square minus 11 times by 2 minus 6. And guys, what you end up with is 2 cubed is 8 times by 2, which is 16. 2 squared is 4 times by 3 is 12. And then you minus 22 minus 6. These are 28, and that's -28. They cancel out, and you get 0. So technique number 1, guys, is using factor theorem. Okay, so once you have a factor, which is 2 in this case, then you start to do your long division. So when you're writing your factor, when you're long dividing, we obviously have our cubic as our dividend. So in this case, we will have 2x cubed plus 3x squared minus 11x minus 6. And guys, then what is your divisor, right? So in this case, we know that 2 was a factor, so then your divisor is x minus 2, not x plus 2, it's x minus 2, because essentially when you're writing this factor down, you get x minus 2 times by a factor that we're trying to find now over here, and you let it equals to 0, right? And then if you solve for it, you get x equals to 2, which is then that's the answer. In this case, x minus 2 is your divisor. All right, so now we do our long division, and guys, with long division, you need to take it slow, one step at a time. So we need to get rid of 2x cubed, right? That's the first term we want to get rid of. Now, what do we multiply this factor by to get rid of 2x cubed? So you can multiply it by 2x squared, because 2x squared times by x gets us 2x cubed, and you minus. So 2x squared times by x is 2x cubed, and then 2x squared times by -2 is -4x squared, and then you minus them apart. This cancels out very nicely, and then 3x squared minus 4x squared gets you to 7x squared, and then you have you bring down the next term, okay, which is -11x. Now what can you do over here? Again, same thing. You need to try to get rid of 7x squared. It's always trying to get rid of the first term available here. So I multiply my x by positive 7x. I essentially try to make or get the same expression, right? 7x multiplied by x is 7x squared, and then 7x multiplied by -2 gets me -14x. And then when I subtract this apart, I end up with -11x plus 14x, which is 3x, and then you have -6 that comes down afterwards. And then guys, it's almost there, we're almost at the end. you multiply this by plus 3 and you get minus 3x minus 6, and guys, you end up with a 0, which is good because long division at the end of the day, if you're trying to factorize, you should always end up with a 0. So like I said, you have x minus 2 as one of your factor. Then what's your second factor? Your second factor in this case is the quotient that you just got over here, 2x squared plus 7x plus 3. So rewriting this, we get x minus 2 multiply by 2x squared plus 7x plus 3. And there we go, guys. We've just turned this cubic into a linear and then also into a quadratic. And further down, guys, sometimes you might not be able to factorize this quadratic, but then in some other instances, you would be able to factorize this quadratic. And just to round everything up, guys, with this quadratic, what do we do? How do we factorize this? How do we know if it's factorizable? Well, you go into what we learned in part 1, right? Now we just have a quadratic expression and we try to use these two techniques. Crisscross method, and if that doesn't work, we do complete the square. So let's have a look. Technique number 1, we always should try crisscross. Does that work? Let's look at the coefficients. We have 2x squared, so that means 2x and x. And then with the 3, well, there's only one pairing without the negative, obviously. That is 1 and 3 or 3 and 1, right? So what's the order? Do I put a 1 here and a 3 here, or should I do it the other way around? Remember, guys, when you're doing crisscross, you multiply them in, diagonally. So 2x multiplied by 3 gets you 6x, and x multiplied by 1, you get x. And if you try to do 3 and 1, what you get here, so if I go 2x multiplied by 1, I get 2x, and then x multiplied by 3, I only get 3x. And then if you add them together, this gives you 7x, and this one over here gives you 5x. So the one we want over here is where the middle term is 7x, right? So in this case, this is the one that works, this doesn't work. So the order actually matters here. Now you go look at the rows. So in this case, x minus 2 stays by itself, but this quadratic expression can be written as, again, the first row is positive 2x plus 1, and the second row is x plus 3. And that's it, guys. There we go. So you've now learned how to factorize this cubic using long division and factor theorem into simpler forms, one in linear, one in quadratic, and then we do what we've just learned previously and how to factorize these quadratic into linear factors. And basically, essentially, writing this cubic expression into linear terms, we can write it as this format over here. Okay, so guys, I hope you found the video useful. Hope you found this crash course helpful for your VC studies. If you did, please leave a like and a comment in the below section if you have any questions. So otherwise, thank you for watching, and I'll see you in the next video.